match. Okay? You've got some values. I'm going back. You can copy now. I'm going back. In your book, you've got some ABG readings. Let's go ahead. I'll go ahead and give you some. All right? You ready? Got a piece of paper? Take it. I'm going to give you some values. We're going to interpret. Okay. Your ABGs, your pH is 7.24. Okay? Now, according to the final rules, number one, you got to identify your pH, right? So is your pH acidic or alkalotic? It's acidic. So very good. Write down next to your value, write down acidic. Okay? Number two of the final rules is you want to identify your carbon dioxide. Well, your carbon dioxide in this case is 66. So is that acidic or alkalotic? It is acidic. So next to that, you write down acidic. Number three, you identify your bicarb. Well, your bicarb is 25. Is that acidic, alkalotic, normal, what? Normal. It's normal. So next to that, you're going to write down normal. Yes? Okay. Next step, mix and match. You've got three values here. You've got two acidic and one normal. Yes? The top one is you've identified the pH, so you know that the problem is that it is acidic. You know it's something acidosis. You don't know what's causing the acidosis, right? So you just went down and you identified the carbon dioxide and the bicarb. And you found out, my gosh, that the carbon dioxide is 66, so that's acidic. So therefore, it must be the carbon dioxide that is causing the acidosis. And remember this rules number one, if it's carbon dioxide related, it's respiratory, so this must be respiratory acidosis. Mix and match. You ready? Let's do another one. Okay. All right. pH is 7.48. Okay? Is that acidic, alkalotic, or normal? It's alkalotic. Write down next to it, alkalotic. Your carbon dioxide is 25. Is that acidic, alkalotic, or normal? It's alkalotic. Remember the rules number one. You cannot take the rules for carbon dioxide and apply it to the rules for bicarb, and you cannot take the rules for bicarb and apply it to the rules for carbon dioxide. Cannot do it. Each set of rules pertain only unto itself. Okay? So your carbon dioxide is alkalotic, correct? Okay, your bicarb is 23. No, sorry. Your bicarb is 33. It's alkalosis. So now if you look at your values, look first at your pH. You know that's alkalosis, right? But you don't know what's causing it, correct? So you went down and you identified the carbon dioxide and you identified the bicarb and you discovered that your bicarb was in the alkalosis range. So therefore, it's your bicarb that's causing the alkalosis, and if it is bicarb, it must be metabolic. Mix and match. Is that easier? It's easier, I know. We're going to do one more. Ready? Okay, your pH is 7.50. Oh, wait a minute. I gave you some wrong values for the one before. I did. Well, if everything is alkalotic, then it's a combination of respiratory and metabolic alkalosis. That's all. Your answer is respiratory and metabolic alkalosis. If everything is alkalosis, then it's everything that's causing it. Got it? Okay. All right, here's your next one. I'm sorry, I got interrupted in the middle of that. So the one before that we just did, your pH was 7.48, your carbon dioxide was 25, and your bicarb was 33. So all three were alkalosis or alkalotic. If that's the situation, then it's a combination of respiratory and metabolic alkalosis. It's called, this guy's going into total body failure real quick. Okay, because there's no compensatory mechanism at work. All right. pH is now the next problem. pH is 7.50. Is that acidosis, alkalosis, or normal? It's alkalosis, right? We've identified it's alkalosis. All right. Your carbon dioxide is 50. It's what? Acidosis. Okay, so write acidosis next to it. Your bicarb is 40. It's alkalosis. Okay, now with ABG problems, we're always determining what's wrong with the pH. Your pH is alkalosis, right? Alkalotic. So you want to determine what's causing it to become alkalotic. It's not your carbon dioxide because that's acidic. It's your bicarb, isn't it? Yes? So the answer to this one is metabolic alkalosis with an attempt to compensate. It's uncompensated, exactly. It's an attempt to compensate. It's uncompensated. Remember, your body tries very hard to always compensate for a problem. Okay? In other words, one good example is if you're hemorrhaging out, okay, and your cells are not getting enough oxygen, what does your body do? It increases your respiratory rate and increases your heart rate, doesn't it? Because it wants to get more oxygen to your cells. It doesn't know that you're losing blood. It just wants to get more oxygen to your cells, so it's compensating. It's the same thing here. Your body, under normal circumstances, tries very hard to compensate. As long as your body can compensate, you're not in too much trouble. It's when your body decides not to compensate that you're up the creek without a paddle, as it were. Okay. Can we talk about lung cancer now, since we're talking about ABGs and breathing and lungs and all this other kind of stuff? Okay, lung cancer. With lung cancer, you need to understand this. We'll maybe do a little bit more than lung cancer. With lung cancer, what you got to understand is this, all right? Number one is that you're going to discover lung cancer the majority of the times too late in the game. Okay? By the time people come for treatment for lung cancer, they usually come because of the pain or because they're spitting up blood. By that particular point in time, it's a little bit too late. Persistent cough, they don't really come. Okay, here's this guy who's smoking 3 packs per day, all right, for the last 45 years. And he's had a persistent cough now for about 6 months. You know what he says? Well, it's because I smoke, so I'm going to get a cough. He doesn't present for that. It's when he starts spitting up blood and coughing up blood and losing weight and getting weak, that's when he comes. Okay? But by that time, the cancer is pretty bad. There are 2 treatments for lung cancer. One is called a lobectomy, and one is called a pneumonectomy. With a lobectomy, what you'll find is that they'll remove 1 lobe. With a lobectomy, you will have chest tubes in place. With a lobectomy also, post-operatively, you are going to tell the patient to lay on the unoperative side. In other words, if they took out a right lobe, okay, and he's got chest tubes here, you want to lay him on the left side, not on the right, because you lay him on the left so that the right lung can ventilate. Okay, that's with a lobectomy if you remove 1 lobe. With a pneumonectomy, that's when you remove the entire lung, the entire right lung or the entire left lung. There are no chest tubes, number 1. And number 2, you will have him lay on the operative side. And the reason is, no chest tubes. Why? Because there's fluid that stays in the thoracic cavity, and you want that fluid to gel up, okay, to fill that thoracic cavity. So because there's fluid filling, you don't want to drain it, no chest tubes. You want to lay him on the on the side that you just took the lung out. Why? So that the other lung that's nice and still working and hopefully healthy can expand. If you lay him on the side of the lung, the only lung that's left, what happens is the fluid here will push on that lung, and that will cause some dyspnea and some discomfort. Okay? So with a lobectomy, chest tubes, and you lay on the operative side. With a pneumonectomy, no chest tubes, and you lay on the unoperative side. Okay, so the good side, in other words. Anytime you have a chest tube, you need to tape all the connections properly, nice and tight. If you still have the misfortune of having a doctor that insists on using the 3-bottle system, the 3-bottle system was invented by a doctor out of the Medical College of Virginia. And even when we went to Pluravax and the rest of us were so excited about Pluravax and stuff like that, not our doctor. He would insist on using the 3-bottle system. So we would have to be tucking them under the bed because we didn't want to trip and fall over it, and that kind of thing. If you have bottles, or even with the Pluravax system, you need to keep the drainage system below the level of the bed. So if you have to transport a patient, the last thing you want to do is put the bottles on the bed with the patient. Put them under the bed. Okay, put the Pluravac under the bed or hang it on the side. Now, NCLEX likes to ask you these questions about the Pluravac or about actually the drainage system. The water in the water-sealed chamber should fluctuate a little bit. It can also have a little bit of an occasional bubble. If there's constant bubbling in the water-sealed chamber, that tells you there's a leak somewhere. Normal is that it fluctuates, okay, especially with inspiration, expiration. Occasional bubble, not a problem. Constant bubbling, problem, there's a leak. If there's absolutely no water, no bubbling, no fluctuation in the water-sealed chamber, you've got an occlusion. You've got a blockage. So there should be a little fluctuation, a little bit of a bubble. Okay? The water in the water-sealed chamber can bubble sometimes with expiration, perfectly normal. Intermittent, fine. Okay. There are 3 chambers. You've got the water-sealed chamber, you've got the drip chamber, you've got the water-sealed chamber, and you've got the suction chamber, right? So the suction chamber has a water level in it. You must keep that water level at the level ordered by the doctor. All right? So if it evaporates, you just got to fill it with distilled water. The place that you want to see constant bubbling is in the suction chamber. You do not want to see continuous suctioning anywhere else. Continuous bubbling anywhere else. Where you want to see continuous bubbling is in the water chamber. And don't ever clamp a chest tube without an order. What I usually tell people is, better not to clamp at all. What you've got to do also with a patient with chest tubes is you need to measure the drainage every single shift. And again, here's your magic marker, your little Sharpie, and you start drawing lines, right? And writing down the time and the date. You've got to measure the drainage every shift. If there's more than 100 cc's an hour, you need to notify the doctor, except immediately post-operatively. Immediately post-op, if you drain 100 cc's an hour for a couple of hours, that's fine. It's normal. Okay, it's when it continues to drain 100 cc's an hour, that's a problem. That's when you need to tell the doctor. If you are taking care of a patient with a chest tube, you need to keep emergency supplies at your bedside, so you've got to have things like a petrolatum gauze or a bottle of sterile water. Why the petrolatum gauze? If he accidentally pulls the tube out, then you take the petrolatum gauze and you slap it right onto the site. Okay, and then you take the other end of you take the tube that he just pulled out and you put it into a bottle of sterile water to keep it sterile. Okay? What you want to tell a patient also is that, look, when it comes time for the doctor, ultimately the doctor will remove the chest tubes. When it comes time for the doctor to remove the chest tubes, what I want you to do is to take a deep breath and hold it. What you're doing is teaching him how to Valsalva. Okay? Because if he Valsalvas, then he's exhaling, then his lungs are full, and boom, out comes the tube real nicely. While you're taking care of the patient, while the chest tubes are in, and even while the chest tubes are out, you need to watch very carefully for something called tension pneumothorax. Okay? And some of the signs and symptoms of that, the number one sign and symptom you're going to see is restlessness. He is going to be very agitated, he's going to have difficulty breathing, and his heart rate's going to start racing. What you will see, which is pretty dramatic, is what we call a mediastinal shift, and you'll actually see the mediastinum moving over and the trachea deviating over. That's a big sign of tension pneumothorax.